Hello, my name is Ashley Goodnight, and this is my Reading Week 10 video. The lecture videos this week covered aspects of a multi-particle system. This included discussion on the center of mass, translation, rotation, and vibration, as well as on the moment of inertia. This week, we found an equation to better calculate the center of mass. Unlike most average values, for the center of mass, we need a weighted average that takes into account the various masses of the system. Note that the center of mass of a system can lie outside of any piece of mass in the system. We talked about translation, rotation, and vibration. When we look at an overall system as a single point, we describe the motion as a whole as translation. In this video, we referred to rotation as a tumbling motion, where the system spins around. This has its own kinetic energy associated with it relative to the center of mass. This is given by the equation rotational kinetic energy equals half times the inertia times the angular speed squared. Lastly is vibration. With vibration, the particles in a system move closer and away from each other like 2 points connected by a spring. There's kinetic energy, part due to the motion of the masses along the x-axis of the spring. However, there's also potential energy. Note that all of these motions can happen at the same time. The moment of inertia touched a bit of my past knowledge. I had heard of the term before and knew it had to do with rotational motion. However, I did not know the expression for the moment of inertia. Note that the omega at the end represents the rotational velocity of the system. Additionally, I didn't know its units were kilograms meters squared. I think the most difficult part of this week's lecture was determining the moment of inertia. Of course, in the lectures, we found the moment of inertia for examples like a rod. However, when it comes to different shapes, I need more work solving them. Luckily, good old Khan Academy has an article titled Rotational Inertia that helped me learn how the distribution of mass affects the difficulty of causing angular acceleration. This week's lessons apply to my major of electrical engineering. We discussed different kinds of motion, specifically translation, rotation, and vibration. These are all important concepts to understand when coding robots. Georgia Tech offers ECE majors a chance to specialize in robotics and autonomous systems. Programming these different robots for diverse environments requires knowledge of all kinds of motion. With that, I am concluding my presentation. Thank you for listening. I hope to see you all next week.